Hi, welcome to my channel. Here I hope to show you better ways of working with software and hardware so you can accelerate your development and deployment workflows using modern, modular, and reliable building blocks instead of tedious manual processes that impact your productivity in the long run. Today, let's take one of the staples of the DIY scene, a Raspberry Pi. If you're a tinker or DIY enthusiast, you've surely heard of or used a Raspberry Pi. It's a cheap, versatile, power-efficient single-board computer that runs a full-blown Linux operating system and is capable of doing many things. There are also a ton of resources out there to help you set it up to do a variety of tasks. However, all of them begin with a base Raspbian image that needs to be manually configured using terminal commands over SSH or requires you to hook up a monitor and keyboard. This is not great for several reasons. It's not scalable or repeatable if I had many Raspberry Pis. Even if I were successful following pages of terminal commands to set them all up, someone else might not be. It follows that the bar for entry is very high, and because of this reason, it prevents a lot of people from using safe and cheap open source software and commodity hardware like the Raspberry Pi, but instead buy into manufactured devices and get locked into planned obsolescence, walled ecosystems that may have privacy issues or security flaws, and ultimately turn you into the product. So, how can we eliminate any manual setup steps, including custom packages, Wi-Fi setup, and configuration without ever opening a terminal window? Keep watching and I'll show you how. First, we're going to build a basic RAS Spotify-based Spotify Connect speaker. For those unfamiliar with these terms, Spotify Connect is a protocol that lets you cast music from your device running Spotify to smart speakers that can then carry on playing that music for you. Using this, your music can follow you around as long as you have devices to cast your music to. RAS Spotify is an open source implementation of Spotify Connect for the Raspberry Pi, which means instead of spending money to buy a smart speaker like Sonos or Echo with all the problems it entails, you can use a Raspberry Pi connected to any speaker of your choice instead. Just like with any recipe, you'll need some materials to follow along. This list is also included in the video description down below, as are links to any software I'll be using. You'll need a Raspberry Pi. I'm using a Raspberry Pi 4 here, but any recent model with an audio jack should work just fine. A micro SD card, 8 GB or more to actually boot the Pi from. A USB micro SD card reader writer so we can write the OS image to the micro SD card. A stereo-to-stereo cable to connect your speakers and the speakers themselves, or a set of wired headphones to test it out. Oh, and you'll also need a free GitHub account to follow along, so make sure you have one before you begin. Let's get started. Let's go over to GitHub, where you can open the PyBootstrap repository from the link in the description. Note that this is a template repository, so instead of forking it, we'll create a new repo based on that template. It's also worth keeping in mind that there are two roles we'll talk about here. One, a developer who understands Raspbian setup, but is keen to share their appliance template with users. And two, the users who only want to use these appliances and don't care about the technical details. If you're only interested in using this appliance template, you can skip forward to the appropriate timecode from the video description below. Now, let's put on our developer hat and create a RAS Spotify appliance template that others can then use to create ready-to-boot personalized images with private data injected securely into the image. We hit the Use this template button, and in the process of creating our new repo, we're presented with a few options. First is the repository name, Raspberry appliance, and put in a description as well. You may be creating a different one, so name it appropriately and give it a description. We also get to choose if the repository is public or private. We're going to create a public repository because this is the appliance template meant to be shared with users, not the private user repo. Anyway, hit Create Repository from Template, and when it's done, you'll be taken to the new repo that's ready for us to use. Because we want to introduce custom installation steps into the image build process, let's open up the Bootstrap folder and look at 02run.sh. We'll leave 01.run.sh alone because it sets up Wi-Fi connectivity, and we'll get to that in the next step. We see that 02run installs Docker and Docker Compose, so we want to replace those commands with the ones required to install Raspotify instead. Let's go with the easy way of installing it for now, and even leave it on default so we can get this done with a single line command. We can directly edit this file inside the GitHub UI and paste the command we need within the on chroot and EOF lines. While a detailed explanation of chroot is outside the scope of this video, suffice it to say that for most intents and purposes, this can be considered a virtual terminal that will execute your commands within the image being built. Of course, users won't have to deal with any of this, as you'll see when we use this template repo later. We can also remove the Docker Compose installation because we don't need it, and commit our changes to the repo. To test it, we'll create a public release which will let us build an image using sensible defaults and no private information. Unfortunately, this means we have to connect a LAN cable to our Pi to test it. Once we've verified that this works, however, we'll move on to the user scenario where we'll inject secrets into the image and make it ready to use and connect to our Wi-Fi network. Once you've created the release, head on over to the Actions tab and wait for the release workflow to complete and download and test the image. The image will be attached to the release as one of the build artifacts. I'm going to skip this step here because I know it works, but if you were creating a different one, here's where you'd test it. Note that free GitHub accounts only come with 2,000 minutes of Linux Actions usage per month, so be careful with those. If there's interest, I'll create a follow-up video on a Bootstrap repo for a Pi-based GitHub self-hosted runner. Do let me know in the comments below if that's interesting. And that's it. This is the simplest version of an appliance template repository that you can create using Pi Bootstrap. Now, let's put on our user hat and use this appliance template that we just created. To do this, we'll create a new private repo. I'm going to call this Office Speakers because this repo will only produce images that go into a Pi meant for that purpose and location. This distinction between a generalized image and a specific one is important when we have custom hardware or capabilities on different Pis. For example, some of them may have IR hats, others may provide audio output to a specific speaker, and some may have cameras and be mounted around your home. And yet others may have a combination of these capabilities. If you're interested in bootstrapping such heterogeneous hardware setups, but in a modular fashion, because that's how we do things on this channel, leave me a comment down below and I'll follow up with a video or example repository. Could you guess how it'd be wired up? Hint. Take a look at the additional mounts environment variable in config and think submodules. Now that we have our private repository, let's try to build an image and try to boot it up. To inject secret information into releases, we'll use GitHub Secrets. Let's navigate to Settings, Secrets, and add in values for the variables in this table. Once you're done, it should look like this, with all the information filled in. Once again, let's create a release. So the release workflow will build our custom image This time with all our Wi-Fi information, custom passwords, and shiny new Raspberry device name. If you're thinking, why release something for your own private repo? It's because this is a good practice, and that's how we do things on this channel. When the release workflow is complete, let's download the image that GitHub Actions built for us. Then we can use Etcher or Raspberry Pi Imager to burn our image onto a micro SD card. Now that we have a bootable OS image, insert the micro SD card in the Pi and power it on. We can wait for the green light to stop flickering, which means it's done with the boot up process. Now the device is booted up, let's ping it using its hostname. There it is, seems alive. Awesome. Switch over to Spotify and see if we can stream some music to it. There we go, Office speakers. Music.
Still wonder if it mattered. Getting my feet back.
And there you have it, folks. A ready-to-use image in an entirely GitHub Actions-based process with a significantly lowered bar for Raspberry Pi adoption by novice users. I'd love to see what kinds of Bootstrap modules you create with this, so please be sure to let me know in the comments down below. If you make something awesome or have any comments or suggestions, I'd love to know. Please like, subscribe, and share so makers like you can work more efficiently and help us all reduce our reliance on giant corporations and their all-seeing, all-knowing devices. Thanks. See you next time.